So welcome everybody to this, the second in the latest series of the Human-Centric Cybersecurity Partnerships webinar series for the 2024-2025 season. Thank you again to the Cybersecurity Revolution, secrev.org, for hosting the content across their channels. Today we'll be welcoming Dr. Jason Jaskolka, who is an associate professor at the Department of Systems and Computer Engineering at the University of Carleton University in Ontario, near Ottawa. And we're also joined as a discussant, Randy Peirce, who is from the Rogers Cybersecure Catalyst at the Toronto Metropolitan University, to discuss the very interesting topic of how we can support compliance with security standards and regulations. And nobody wants to hear me talk, so we will move very quickly to get into the presentation. And welcome to the floor, Dr. Jason Jaskolka.
All right, thank you, Michael, for the introduction. Hello, everyone. So today I'm going to be talking a little bit about supporting compliance with security standards and regulations. As we heard from the top, I'm with Carleton University in Ottawa, Ontario, Canada, from the Department of Systems and Computer Engineering. So where I want to start our discussion today is this idea of complying with security standards and regulations. Now, one of the things that we need to remember is that there is a huge landscape of cybersecurity standards with a number of different organizations that are providing these documentations of best practices, guidelines, standards, all about implementing and evaluating security for various types of systems. And really, what we have to be aware of is that when we're developing systems, new or old, in many cases, we need to show that we comply with some subset of these security standards to help show that we are doing something about security, so to speak. And this is sort of the way that we talk about standards, right? Is, wow, we have to comply with them. We have to show that we're doing something. The challenge really comes into this space when we think that there are so many different standards, and the selection of these standards for different systems is often a major challenge. And in some cases, we have to think about what can all of these different standards groups and various standards themselves bring to the table. There's this great quote that I've heard time and time again that says, the nice thing about standards is that there's so many to choose from. So when we're choosing standards, we have to think about the different kinds of coverage that they provide. Now, when we look across the various landscape of cybersecurity standards, there are some that provide very moderate coverage and some that provide much more comprehensive coverage. And the purpose of this talk isn't to go through all of the details of this varying level of coverage, but rather just to give some context to where we're going with our discussion, is that at some level, when you're trying to comply with these different standards, we have to understand what exactly they're providing to us. Now, this becomes increasingly important when we start looking at the development of critical systems. So when I say critical systems, I mean the kinds of systems that we'd find in water and wastewater treatment facilities, that we'd find in low Earth orbit satellite systems, for example, that are providing communications and connectivity for people around the world. Manufacturing systems, power grids, energy grids, these sorts of things. These critical systems are really the kinds that demand these increased levels of security and resilience in order to provide those assured services to their customers or their consumers. So as a result, these are the types of systems that really need to demonstrate compliance with a variety of security standards, of a variety of policies, and sometimes regulations. And that needs to be demonstrable throughout the system development lifecycle. And this is really important for supporting that customer's trust and ultimately finding the widespread use of systems, especially on the consumer side. Now, what really is the challenge here is these types of systems have, in many cases, multiple standards to which they need to comply. And in many cases, these standards can be overlapping. And what I mean by that is that this overlapping means that I have perhaps several different standards documents that provide certain kinds of requirements that my system needs to adhere to. And they all say the same thing, but in different ways, and sometimes with different granularities and different levels of specificity. So trying to sort through those overlaps between the standards when you need to comply with multiple standards, regulations, and sometimes even policies or guidelines requires a significant human effort. People going through these documents really takes a lot of time and effort. And the procedures that look at post-development testing and patching of systems, trying to make them compliant with these standards sort of after the fact, ends up being very time-consuming. It's very costly. It's really prone to overlooking a lot of potential security vulnerabilities as well. So because of this, there has been this new notion of compliance by design, and sometimes it's referred to as compliance engineering. And really, this is a paradigm that's aiming to engineer systems and build systems that meet the audit requirements for standards, in our case, security standards, and their requirements at the early stages of development, typically in the design stages. So with this idea in mind, our research challenge is really looking to address the need to improve the effectiveness and the efficiency of the security requirements elicitation and control selection processes that typically come from or are informed by cybersecurity standards, so that we can ensure compliance with these standards, policies, and regulations for what we're considering to be these critical software-dependent systems. And really the question we're asking ourselves is, how can we support this security compliance checks at the early stages of development to help streamline these processes and to reduce that human effort that's involved? So this is really what we're aiming to do. So in order to address this challenge and to answer this question, we've developed an approach that enables us to develop models for understanding compliance and checking compliance in the architectural design of software-dependent systems. So the approach looks a little something like this. So what we have here is two main sections. So the left-hand side is really focused on the development of what we're calling the compliance models. Now, the compliance models are really focused on understanding what information is coming from the standards, the policies, the guidelines, the regulations. So these are all of our standards documents. And what we're going to look at, and I'll explain sort of the details of all of this as we go along, is we're going to derive from these standards, policies, and guidelines a set of baseline security requirements. Now, what's going to happen is we're going to have a number of folks involved in this process, and we're simply categorizing them by a particular role we expect them to play. So we'll have somebody who we consider to be a compliance expert that will help to develop security compliance models that are representative of these baseline requirements that are extracted from the standards. And we're going to have security experts that are helping to identify and define security controls that help to address those compliance requirements that we would identify from these standards. Now, we're also going to have someone we call the analysis expert, and they're going to be involved in actually interpreting those models so that they can be used in the development process by the architects and software developers. Those folks are going to be charged with developing a model of the software architecture, basically the design of the system, and doing the compliance analysis to see where and how they are either complying or not complying with those baseline requirements that were extracted from the standards. And this may be an iterative process where they're going to look at performing this compliance analysis, improving on the findings that they have from the initial analysis, and then doing it again and again and again until they reach a point where they find that they comply. Now, all of this has a lot of process that goes behind it, but the main idea here is that we want to develop in the box that's labeled A, model libraries. We want to develop these compliance models and controls models so that they can be reusable in specific application architectures that the architects and software developers would be using. And this is a way that we want to support this compliance checking, because at the end of the day, the standards to which many software-dependent systems need to comply are often the same group of standards. Of course, each system is going to have some application-specific or industry-specific standards that may come into play, but generally speaking, we can look to extract those baseline requirements, model them, and then use them in this process over and over and over again for different kinds of systems. And that again can help with some of the cost in developing the overall approach here. So where I'm going to go with this talk is really breaking down the different steps of this approach and allowing us to see what is involved in this process and how we can ultimately support the architect at the end of the day who's developing this system in checking compliance with the standards and regulations that they may need to comply with for their particular system. So in order to understand this, let's have a look at an illustrative example that I'm going to carry through our process here. So this is a general SCADA system. So the architecture that you see on the left-hand side of the slide is the basic reference architecture for just about any SCADA system. It comes from a NIST standard that describes SCADA. SCADA is simply a supervisory control and data acquisition system. And these kinds of systems are really designed to control and monitor assets through data acquisition. So what they do is they collect data, they make decisions based on that data, and then they act upon it in order to control certain kinds of processes. So a typical use case where you might find this type of SCADA system is in a water or wastewater treatment facility, which is depicted up on the top right-hand side of the slide. And on the bottom right-hand side, you'll see sort of this process control type figure. And that's really just the physical hardware that the software is monitoring in a system like this. So the basic idea here is that you're going to be monitoring the wastewater and you're going to be checking for particular chemicals, things like this, and treating it in a way so that it becomes safe when you have to discharge it out into the environment again, for example. So one of the challenges that exists when securing these kinds of systems is that firstly, a SCADA system consists of hardware and software and networks that interconnect all of these different components. They have typically one or more control centers. They usually have a number of field devices that could range anything from sensors that are sensing certain aspects of the environment to actuators that are controlling various physical components like pumps, for instance. Now, when SCADA systems were first developed, security was not really a primary concern because many of these systems really weren't accessible via the internet. But that has changed quite dramatically over the past decade or so. And now we have to carefully consider cybersecurity for these types of systems. And the good news is that there are various guidelines and standards that have been developed for these particular types of systems. So one of the first things that we're going to uncover when we look at this illustrative SCADA system is that we have a set of applicable security standards and policies that may be applicable for the development of such a system. So the first one we have is the NIST Special Publication 800-82, which is basically a guide to operational technology security, and it provides guidelines for securing industrial control systems, including those that would be used in the water or wastewater sector, for example. For the purpose of our discussion, we're also going to consider CNS policy number 1253, And this establishes guidelines and requirements for securing national security systems. And this includes critical infrastructures, again, like water and wastewater systems. And lastly, we're going to look at another document. This is more of a US specific document, but the same general ideas can apply with others, of course. But this is the Office of Management and Budget, OMB, Circular A130. And this provides guidance on the management of federal information resources to ensure that wastewater treatment implementations, for example, align with broader federal guidelines promoting some consistency in security practices across these different critical sectors, for example. So what we want to do and what we're going to describe throughout the rest of this talk is how do we ensure that when developing or designing a SCADA system like one that would be used in a water or wastewater treatment facility, how do we ensure that it complies with each of these standards and guidelines? So here's a case where we have three documents that all are going to prescribe some aspects that we need to ensure for the cybersecurity of our system. So in order to do this and to manage compliance with all three of these documents, we're going to start by extracting that security requirements baseline. So in our context here, the standards, policies, guidelines, those are going to be those three standards documents that we just saw on the previous slide. And we're going to now look at how do we go ahead and extract what are the actual requirements that we're going to need to comply with for the purpose of checking our eventual software architecture. So we've done some work in developing an approach for doing this extraction. And this comes from two main inputs. There's the target standards and or regulations. So that, again, that's those three documents that we just talked about. But there's also the description and context of the system. So in our case, we're going to focus on this wastewater treatment facility as our system, a basic idea of a SCADA system. So the first thing we're going to want to do is extract the constraints from these standards and regulations. So as soon as we know what our system is, we identify those target standards and regulations. So selecting the applicable standards is really always the first step. We need to know what standards we need to comply with. Once we have those, then what we want to do is identify the parts that are addressed by the software architecture design. Now, this is important in the work that we do because in the standards documents, there's going to be a wide range of requirements and prescribed security controls, but not all of them are going to be technical controls that are things that you implement in the actual software of the system. For example, many documents will have prescriptions about awareness and training programs for staff, employees, and personnel, for example. This, however, is not something that at the architecture design, we can actually work into it. So for this purpose, we're going to leave compliance to that as a separate process. And we're going to focus more on the technical controls that can be addressed in the design of the system itself. So once we extract all of those different parts, what we're going to do is we're then going to start looking to overlay the requirements that come from the various standards. So again, in our example, we're considering these three different standards. And what we're going to do is we're going to identify one that we consider to be the primary standard. The primary standard is typically the one that is the most general. Often case, this becomes these kinds of NIST standards that are very much broadly prescribing requirements, saying, for example, you need to encrypt data, but without any further detail than that, for example. And often case, when you go into more specific or industry specific standards, they'll have further constraints over which or on the ways in which you can provide those particular kinds of controls. So this overlay is looking to find how can we basically identify the requirements that come out of each of those different standards and put them together so that when we comply with this overlaid requirement, we're actually complying with all of the standards simultaneously. So this overlaying process really results in what we call the mandated security constraints. This is really describing what we have to comply with. And then from the security baseline perspective, establishing that, we apply those constraints, and then we are basically looking for where in the design of the system will we be able to apply those constraints? Where should it be applied with respect to the different components of the system, for example? And ultimately, once we have that, then we rewrite those requirements as security requirements for our software architecture, and that's effectively what our security baseline is. So when we actually perform this process, we have something that looks a little bit like this. So the basic idea here is that in this table, we're first doing the mapping of the basic control categories that come from the primary standard that we've identified. So in this case, we're using the NIST Special Publication 882 for this purpose. And in that standard, we have a number of these categories. So for example, there's a category of access control, which we're deeming to be relevant for the architecture design of the system. Access control is something we can actually implement and design into the system. As at the same time, we again have things like awareness and training, which isn't so relevant to the architecture design of the system. So we're really just finding this mapping of which categories are relevant. So I'm going to focus your attention down on the highlighted category here, which is systems and communication protections. So with this particular category, we're then going to look in the details, and we're going to start finding the relevant parts of the target standards that are useful for our software architecture design. So we're basically going one level deeper into that standard now, and we're going to find, again, when we look, we'll find transmission confidentiality and integrity. Again, very general sort of description of what we need. But when we do this for all of the different standards documents that we have, we actually find something similar in each of the different standards. So for example, when we look at the CNSS policy, we find that we require a NIST FIPS compliant and NSA approved encryption standards to be used. And when we look in the OMB A130, we find even more details about how we have to provide protections against unauthorized disclosure of information and so on. So when we bring all of this stuff together, what we're actually finding is that we can overlay these different requirements, and we can say, well, what are we really asking for here? We're asking that we protect the data that's being transmitted using FIPS and NSA approved algorithms for the protection of this information. So this is really the idea that we're going for here, is we're going through this mapping process to identify these requirements that come together, that basically combines the essence of each of these requirements with the levels of specificity that all of the requirements from the different standards provide for us. So when we carry this forward, we then go to the idea of mapping this back to our architecture. Where do we then apply this constraint, right? So when we think about where we would have this transmission of data in our SCADA system, well, we can find that that's going to be between the control center and the different field sites that we have. So basically, we look to our architecture and we say, well, this is the place where we need to provide this kind of security control. And ultimately, once we've put all this together, we get our software architecture security requirement that's basically going to describe that all of the communication channels between our control center and our field sites must have a NIST FIPS compliant or NSA approved encryption in order to provide the confidentiality and integrity confidentiality, integrity, and availability of the information that's being passed there. So all of this work is very time consuming for a human to do, as you can imagine. And the good news is that when we look at things like industrial control systems or SCADA systems, for example, they typically comply with these same sets of standards over and over and over again. So what we do find is that if we can do this well once, we can then reuse this information over and over and over again for different kinds of systems. So when we go through this exercise of establishing the security requirements baseline, that can be very helpful when we encounter the same combinations of standards time and time again for similar types of systems. Now, that's only one part of the story. The next thing we need to do is use this requirements baseline to actually check compliance with respect to the rest of our system. So in order to make this requirements baseline actually usable for the purpose of compliance checking, we need to actually develop models of these compliance requirements and the controls that may be used in order to address those requirements. So in order to do this, we developed a domain-specific language that would be used by the development team to specify the various requirements that they have. So the basic idea here is under the hood, and I'm not going to go through all of the details of all of the formalization of everything here. Instead, I want you to get the idea of what we're doing. So the basic idea is that we specify the libraries of requirements that come from each of the standards. So for example, here on the left, we have the requirement coming from the NIST standard. On the right, we have the requirement coming from the OMB circular. And we provide the overlay, which combines those two specific requirements that basically gives us that protection of our transmitted data, complying with the FIPS or NSA approved algorithms, for example. And what we're going to then do is have another set of security controls, and these can be the typical controls that also come from many cybersecurity standards that are control catalogs, for example. And the security expert is going to be using those to map to specific requirements that need to be satisfied. So for example, in our case here, the security expert may find that using TLS, transport layer security, is an appropriate control for providing the confidentiality, integrity, availability using the approved algorithms that would allow our software architecture to then satisfy this compliance requirement that we have. So it's really this idea of we're going to formalize all of these things so that we can have later the architect picking and choosing off the shelf what they need to comply with. So there's this upfront work that happens by the compliance expert and the security expert in providing these libraries so that the architects who may not be compliance or security experts can use this information to perform those checks when they're developing these new systems. So once we have those models, the next thing we need to do is provide a way in which we can actually check whether or not those requirements are satisfied or not satisfied in our system. So this is what we call the analysis models, and this is going to be something that's done by an analysis expert. Now, an analysis expert is going to be someone who has a skill or a background in formalizing requirements. In our case, we use a formal language called Alloy that allows us to precisely specify what exactly these requirements are saying in the context of the software system that we have in terms of communication among the different components that we have. So for example, each of the requirements are basically trying to verify that the system ensures that the payload of some transmitted message can only be obtained by the authorized components, and that every received message is in fact authentic. So long story short is we have a way of translating what that says into a formal, more mathematical language that provides that precision to precisely say this is what we mean. And at the same time, for the other requirement coming from the other standard, we do the same sort of thing, verifying whether the system actually ensures that all of the senders of messages are in fact authentic. And the overlay is just the combination, checking that both of these are satisfied at the same time. And again, TLS is appropriate to ensure that these compliance checks will pass. And that's something that we're going to want to include in the development of the system. Now, again, this is something that can be developed as a library and that can be used behind the scenes. So what we do is we provide basically a simplified language that will allow the users of this approach to not have to worry about all of this formalization. This stuff all happens for the purpose of doing the checks behind the scenes. But really what the architect is going to do is they're going to be able to then use this machinery, if you will, and they're going to focus simply on developing their application architecture. So they're going to develop the software application model, and they're going to then perform the security compliance checks. And this may be also done with help from the software development team as a whole. So what does this mean? So this means that we're going to have our architect, and they're going to take, for instance, their application model, their SCADA architecture in our example, and they're going to then define that architecture. So they're going to have a simple language that says we have some data and we have a certain set of components, and those certain set of components are going to be connected in particular ways. So they're basically going to describe the system and how it's supposed to work and how it connects together. Okay. Then what they're going to do is they're going to then, with that model of their system, check whether or not they have the compliance to those requirements that we've identified from the baseline. So we're going to check the overlay requirement that we have, which is really the combination of the different requirements from the different standards. And we're going to check that in the context of the specific application. So in our case, we're going to check, well, do we have this requirement being satisfied between our control center and each of the field sites that we have in our system? In our case, we have 3 different field sites. And as a result of all of this, the analysis models that we developed will be used in order to check whether or not these requirements are satisfied or not. We take all of that and we provide a report that basically shows what is going on. So our compliance analysis will basically say something that says, for example, the status of compliance between the control center and the field site number 1, for instance, is not okay. What this basically says is we don't comply with this requirement, and therefore we're not compliant with the standard as the system is designed currently. So this report then can be used as feedback for the architect to say, okay, well, I need to then do something in order to ensure compliance. Well, what we do in our approach is we also have some additional information that we can use to provide some hints back to the architect in order to help them in becoming compliant, to support them in this process. So as part of the report, it says, for example, that there are some suggested security controls, one of which would be the TLS control that we've been talking about a little bit earlier, for instance. So what happens is behind the scenes, this compliance analysis is happening. That's what's really generating this report that we had seen. And from there, the architect again takes that feedback and they can add those security controls. So they can go and they can revise their model to say that, okay, we also need to have a security control between our control center and our field sites that ensures that the connection between those components is using a TLS connection, a secure connection. Once we have that in place, we can then run our compliance checks again, which is no different than what we did earlier. And then we get a new report that basically is saying that now we have that requirement satisfied and compliance between the control center and our field site is now okay. So we can imagine expanding this out for all of the requirements that happen within our standards documents. And we can then use this to generate the evidence, for example, that we have in fact complied, at least at the design stage, with the requirements that are needed for securing the specific system that we have. Now, again, it's important to emphasize that we're complying with the specific technical requirements, not necessarily all of the organizational and managerial requirements that would come from the standards as well. Again, those will have different processes. In this work, we're focused really on the technical side of things. So taking all of this together, this provides us with an approach that allows us to support this idea of compliance by design from the very early stages of development. And this is beneficial because it helps the architects and the developers to ensure that their designs are on that path towards compliance to their critical security requirements from a very early stage where it's less costly to make the changes. So for example, when you think about identifying at the design stage that, hey, you maybe need to add some security controls to your design, that's rather easy to do. And especially given the support tools that we've developed, that becomes rather straightforward. That then helps to drive the development of the rest of the system. It's much more difficult and much more costly to make those changes after you've already built and deployed the system, for example. Our approach also helps to support the reusability of these kinds of models that we've developed to streamline the compliance checking processes. This becomes particularly helpful for systems that need to comply with the same or similar sets of standards, as I mentioned earlier in my talk. However, it is important to acknowledge the fact that there is an upfront cost to developing these models. They don't come for free. They are something that needs to be developed with expertise in doing so as well. But once we have them, we can then reuse them, and that's really when we start to reap the benefits. And the last thing that I'll mention here is that having this sort of automated analysis and tool support, so all of the process that I described here has appropriate tooling that the architect uses in order to check for those compliance checks, and that's what generates those reports. That helps those human analysts in that compliance checking, making sure that they are going to have a systematic and complete process with a reduced human effort. We're never going to get rid of the human effort that's involved with this, but we can at least reduce it. So with that, that's really the concluding remarks for this presentation. We do have a number of related publications associated to what I discussed today. So really there's two main works, one about eliciting the architecture requirements baseline from the standards and the regulations, sort of the first part of the process, and then another work describing really the entire framework using the reusable formal models that we've developed. And with that, I will thank you all very, very much for your attention, and I'm happy to turn it over and have some discussion about what we've just talked about. So thank you again.
Apologies for the delay there. Thank you very much, Jason. That was very interesting. I'd like to remind anybody who's in the audience at the moment that if you have a question, please put it in the chat, and I'll let you know that there are, depending on which platform you're watching us on, up to 3-4 minutes of lag between us and you watching it. So put your questions in as early as possible to make sure that we can get to them at the end. And with that, I'd like to introduce Randy Purse from the Rogers CyberSecure Catalyst, who will be making some comments and discussing the the presentation as put forward by Jason. So with that, I'll hand it over to you, Randy.
Thanks a lot, Michael. Jason, excellent initiative on your part. I think that this is a very interesting topic in particular, just to put a cap around the issues of compliance as it pertains to cybersecurity, and in particular with critical infrastructure. One of the things you were talking about with respect to compliance and early stage development, and you highlighted the point that in many cases, these organizations that are supporting operational technology or critical infrastructure may not have sort of the security expertise in order to actually be able to properly filter the compliance requirements and the standards that are needed to support this. So it was really interesting to hear about that. What is your sense about you know, how architects and developers are potentially going to be able to use this, or how well they'll be able to use this in their initial design and development? What kind of uptake do you anticipate based on this? Because I think you're bang on. They don't necessarily have the expertise, and it's very difficult to filter all those standards.
Yeah. So there's really two parts to this, right? Developing those compliance model libraries up front is really the hardest part of all of this. That's where it requires that sort of expertise to go through the standards documents, really understand what they're actually trying to do. And then for the architects, really what we're trying to do is those are the folks that are just trying to develop the system. They're already stretched way too thin. They can't be not just the architect, but the compliance expert and the security expert and this and that. They can't wear that many hats and expect to do all of this stuff well. So our approach really does focus on collaboration among these different folks that have different expertise. In terms of uptake, it's really about providing the appropriate tools that allow the architects to easily do this kind of compliance checking. So what we're focused on, and this goes beyond just this talk. Really, my entire area of research is focused on how do we support these folks in doing more security analysis when they have limited time and limited resources. So we want to develop approaches that integrate with the tools that they're already using. So for example, in model-driven development, which is often used in critical systems development of various kinds, there is the open source Eclipse modeling tools that a lot of people end up using. So the framework that we've developed integrates with the Eclipse platform. So right then and there, they can specify their architecture, use the libraries with the editor, and it's basically a click of a button and it generates that report. And that, I think, is really the key to the uptake of something like this. If you're asking these people to jump through more hoops than they already have to jump through, I think that's where we're going to end up having some trouble. So right now, we're still at early stages of developing more of these model libraries. It's at the stage of showing the proof of concept that this all works, but developing those model libraries is something that I think deserves a lot more attention, that can facilitate everything else that comes after it.
Yeah, and I think your discussion around security by design, security by default, and many countries have already endorsed those as, at least by principle, that organizations who do design and development of software and systems have these principles embedded in their processes. But the thing about compliance requirements, it's exhausting, right? Just filtering through those standards. So you're absolutely right. If there's something that'll help them do that, that's amazing. And to be honest with you, even the body of knowledge that they have to have in order to filter the standards appropriately, in order to figure out how it applies to their system and their sector, is quite large. Yes, there's specialists in those areas, but these people, like you suggest, aren't necessarily specialists. So that's really a key factor.
Yeah, exactly. And that's what the libraries are intended to do here, is to basically be general and reusable, where the architect is the one who knows how everything's going to connect together. And I didn't go through the details, admittedly, in the presentation, for good reason, but the libraries are parameterized by either components or connectors between components, which allows you to basically put them in place where you need to in the specific architecture that you have. And that's what the architect knows. That's what their job is. That's the thing they do well. And from a compliance perspective, and quite frankly, this is how standards are in the cybersecurity world, is they can't prescribe it at that level of detail because it needs to be applicable to various kinds of systems and things like this. However, there are different kinds of standards, different ones that are very general, very broad, sort of apply to everything. And there are more industry specific standards that get to the nitty gritty, that if you're building this type of system, this is how it has to be. And that's the case with these more industrial control systems, critical infrastructures. I gave the example earlier on about low Earth orbit satellites. When they're used for specific purposes, like government contracts, for example, they have a very particular set of specific requirements that they need, but they still need to comply with those very general requirements as well. And what we're hoping to do is can we sort of double dip here, where we can identify that complying with one complies with the other, and actually provide the traceable mapping of that, because it's very intuitive for someone digging through these requirements to see that overlap, but to really understand how it works is the challenge. And that was the challenge in that part of the work, is really doing that mapping, which is heavy lifting, if I'll call it something.
Yeah, for sure. When you're talking about the reusability of these, and this is exact, I mean, for manufacturers, for organizations that are working
Yeah,
in systems or services, obviously they're doing more than one, right?
yeah,
Typically. So this repeat with different clients. So this repeatability across a
yeah,
client base is an amazing opportunity for them to not have to reinvent the wheel with every product that comes out, and but also provide. Now there's a potential for them to provide. So they have a new project, there's potential for them to provide slightly different parameters that they could put into the model library to say, okay, this is going to be serving a different client with different specific requirements. So what does this mean with respect to compliance? So there's opportunities for that.
yes, absolutely. So the basic idea is to have the library in exactly that way, where it's especially for sort of your um, to be a bit cheeky, your heavy hitters of security standards are the ones that creep up over and over and over again. You would have those libraries that you basically use off the shelf because they're going to be applicable across that wide variety of systems. But standards themselves, and in particular, a handful of the NIST standards, are intended to be tailored to specific contexts. So there still is that necessity to provide the model libraries in such a way that they can have that tailoring. And that's also what the overlay mechanics do as well, where it's almost like you have your base standard and then your specific constraints because of your context. While that might not be formalized in a standards document by a standards body, for example, it may be a policy of a particular organization or company. Um, that can be used in exactly the same way, right? For the purpose of these types of requirements, for example, we use the NSA approved encryption algorithms, no matter what, even if we can choose something else, that's what we do. That's sort of an organizational policy. You can encode that same sort of thing. The idea here would be simply capturing that in some documentation. And again, you would need that upfront cost of setting it up to begin with, and then it's reusable off the shelf afterwards. And again, that upfront cost is always the sort of thorn in the side of an approach like this. But that's with any of these sorts of by design type paradigms. Is there's this promise of, if you spend the time and the effort up front, it will ultimately save that time and effort later on. Yeah.
And that's the argument, right? It's not just about the upfront cost is also helping to defer or mitigate significant risk at the back end.
Yeah.
If you don't do it now, not only will you have additional add-on costs with the architecture, but you may have some litigation costs, you may have environmental costs, you may have, so there's a whole raft of potential risks that you're mitigating as a result of doing this up front. Even though we know compliance doesn't equal security necessarily, at
Yeah.
least it gives you that baseline like you're talking about. So that's really important. I think that's and so what about the maintenance of these libraries? So I know regulations move at the speed of turtles.
Yeah.
However, what about the industry standards can change almost overnight sometimes, particularly in some of the more innovative spaces. What about the maintenance of these libraries?
Yeah. So that will be a challenge. But again, the fact that they would be developed as a library uh, allows for them to be updated. And if you and this is just the way the tooling is set up, is that if you have a new version of that library, you push the new version of that library, you can rerun those analysis checks right away. That's sort of the nice feature of that kind of push button analysis, and check compliance against the new version. Now, again, that will require that cost of going and identifying what was changed from previous version to new version, and translating that back into the models. But generally speaking, the models aren't so, at least in our experience to date, I will sort of qualify it by that. They're not so wildly complex that that kind of maintenance task becomes very challenging. It's much like updating any other sort of software library. Um, Changes don't usually come in sort of these big bang kind of approaches. They're rather incremental refinements, and that's the same for these kinds of libraries. That's how we at least see it so far. Um, there's not a
Yeah,
ton of evidence to support it much more than that, but
no, but I
so
would
far so
suggest
good.
you're right, right? I would
Yeah,
suggest you're right in that these standards, even though they may get changed quite regularly, I mean, you saw NIST Rev 3 there as an example,
yeah,
okay? But that
yeah,
was actually, that reversion happened over several years, right? So
yeah,
it's not as if these happen, but as we see in certain systems, you were talking about satellite systems as an example. Well, we could learn something today and the standard could change tomorrow. But like you said, if you're already using the library, you're at least, you know, you've got compliance to here. So now it's just about gap filling in that space.
yeah,
That's good. The other thing that struck me when we were talking about these is that this is excellent for compliance audits after the fact as well, right? So you just use these models, go back in the library, press send, and let it analyze against what you have, and that will also help to for people to be able to define the difference between compliance versus risk, and what are they using to scope out risk, and what controls are applied specifically to risk, and what controls are specifically applied to compliance. And often, again, there's overlap, but that was a very interesting thing to be able to reuse them in terms of audits, right? And checking systems and things like that.
yeah. To be quite frank, that this problem came from some industry partners that we had that were describing exactly this challenge. Is that when we have to do the auditing, for example, we need to be able to trace back everything. Where is this control? How is it used? Why is it here? All of these kinds of questions that you get in that audit process, that drove really why the compliance reports look the way they do. Because you can then say, I performed this check, here's my process. It said it wasn't compliant here. It gave this suggestion. I followed the suggestion. Now it works. Everything's okay. And you can sort of trace everything from beginning to end. And well, that's a lot of information to manage. Again, having the support in these kinds of systematic approaches and tools facilitates all of that. Allows you to focus on answering those questions well, rather than scrambling to scrounge up whatever you can to satisfy the auditor, for example.
Excellent. I think another feature to this that I was impressed with is the human in the loop in the front end, right? You're gaining and gathering the expertise in both compliance and security at the front end, so the security architect doesn't have to do that work, right?
Yeah,
And that's, or sorry, the security architect should know what they're doing, right? But an architect, right? Architect,
yeah,
engineer, developer, whatever, and that's really important. And these inputs at the front end certainly help kind of streamline the process as you suggest. But that important, the at least until we get to a point where our AI agents are all switched
yeah,
on to all these dynamics, which they aren't. That human in the loop is going to be critical, and certainly in the design process, right? That check
yeah,
in the system is
yeah,
important. Do,
yeah.
do you have any observations from that? The
So,
where humans are going to need to be paying attention to this.
so in my view, so we've had some questions about this work of, well, why can't you just have the AI extract the security baselines? And it's
Yeah.
like, yes, that would be fantastic because that's really the painful part of all of this. But I don't think they're there yet to understand all of that nuanced context that really you need those compliance experts, those analysts to go through and truly understand. Maybe we can get there in time, obviously, but right now I don't think we're there. So those folks are critically important at this stage. In my view as well, we're also going to be looking at the human architect is always going to be a part of this. You're not going to have that person be replaced, in my opinion. That process is innately an art and a science, and it's that perfect marriage of art and science that leads to good, solid foundations for the systems that we build. And I just can't see that person being replaced by machinery. And those are the ones who are tasked with ensuring that all of these different characteristics, whether it be security, safety, reliability, all these qualities that are all pulling in opposite directions, are in fact present in the final product. That is really where I think it lies.
I'll
Yeah,
I'll
excellent.
jump in here quickly with a question for Jason and for you, Randy. Uh, a lot of these technologies with cybersecurity generally sort of scale in reverse, in that they start with very large enterprises where they're developed specifically for that enterprise, and then they sort of make their way down to smaller and smaller enterprises, becoming sort of their own product and available for all of the way down to individual users. How do you see this product, given that it has a security architect involved in its implementation? Do you see this as a kind of technology that will scale all of the way to the individual, or is there a point at which it might necessarily stop?
Personally, the approach that we have requires the collaboration of those experts that we show in the process. So I don't think it will get down to sort of a team that doesn't have that expertise. At best, it can get down to a point when the libraries are developed fully and those compliance and security experts have done their job and they kind of share that knowledge and experience through the libraries to everyone else. Then maybe a very small organization could manage this. But again, we sort of look at this through the lens of teams that are developing these critical systems, and it's very much those kinds of teams have a certain size and shape to them as well, right? So that's sort of how this was developed in mind. I don't know if that really answers your question, but sort of where my thoughts are with your question.
I suspect, Jason, that you're right, but I think what happens, particularly within this community, is that we tend to look up towards our models, right? The larger models. So the organizations that are using these techniques and using these tools in order to do stuff, the smaller organizations are going to likely adopt. Plus, they'll gain the benefit and the experience of these larger organizations in doing it. Like when you think about SCADA or energy as an example, energy is sort of out front in this. Okay, so water systems, maybe not so much right away, but maybe soon, right? And so that I think they'll see. We often refer to, okay, if energy's out front on this, what's going to happen now, and how do we take the lessons learned from energy and trickle it down? I think the same thing applies in this case with compliance, is that it will trickle down into other sectors and into other small medium enterprise. Whether or not they'll be able to leverage the same sort of depends on the level of design and the level of development they're going to be engaging in as a small medium enterprise. But I think there's a benefit to it as we see this run out over time. So I think it's a great initiative. Thank you very much for that.
Thanks.
And with that, we'll draw the stream to a close. Thank you very much to Dr. Jason Jaskolka for his presentation, and to Randy Purse from the Rogers Cybersecurity Catalyst for your comments and your questions. Very interesting stuff, and we look forward to the next webinar that will